Hello learners, welcome to our interesting and innovative series of videos on electronics and robotics. You know what? I loved playing with electronics in my childhood and I still do. I used to wonder whether how my remote controlled car works, as how LED of my toy glows with amazing patterns and colors. Let's talk about all these interesting topics in this session. Electronics is everywhere. Home, offices, transport, space, and almost everywhere you see. Have you ever thought how your LED watch works? How your mobile phone works? There is always a small concept running behind a complex machine. There are millions of circuits running in a simple electronic device. Have you ever thought how the flow of electronics running through various conductors and semiconductors helps to make an actual circuit? Yes, there are millions of components with different properties mounted and assembled over a single PCB board, which helps making metro move, plane flies, mobile communication possible, and other unending possibilities. Isn't it interesting? Yes. So why get late? Let's get started. Let's have a quick look to what are we going to learn in this video sessions. In the sessions, we'll learn AC and DC, semiconductors, basics of electronic components, register color code, and circuit symbols. Let's talk about AC and DC first. Electricity comes in two different forms, alternating current and direct current. Both are essential to enable the functioning of our electronics. But do you know the difference between the two and why they apply to? Let's talk about AC power first. Alternating current is the standard electricity that comes out of power outlets and is defined as a flow of charges that exhibits a periodic change in direction. If I talk about direction, AC current flows positive and negative because of electrical current come from the flow of these electrons, which can move in either positive, that is upward, or negative, that is downward direction. This is known as sinusoidal AC wave, and this wave is caused when alternators at power plants like hydropower plants, wind power plants, solar and nuclear power plant, etc. creates AC power. Alternators creates AC power by spinning a wire loop inside a magnetic field. Waves of alternating current are made when the wire moves into area of different magnetic polarity. For example, the current changes direction when the wire spins from one of the magnetic field poles to other. This wave-like motion means that AC power can travel farther than DC power, a huge advantage when it comes to delivering power to consumers via power outlets. Now, let's talk about DC. So what is DC power? Direct current power, as you may guess from the name, is a linear electrical current. It moves in a straight line. Direct current can come from multiple sources including batteries, solar cells, fuel cells, and some modified alternators. DC power can also be made from AC power using rectifiers that can convert AC to DC. The AC power generated from the power plants is sent to the substation, which is located at our area, districts and societies. The substation sends that AC power to the transformer, which is further stepped down to 220 volt and made compatible to the home supplies. The home supply, that is 220 volt, is again rectified through rectifiers to form DC, and that DC power can be further used by our electronic appliances. The supply from the power stations are very high, so the transformer are used to transform the higher voltage to the lower voltage. As well as in electronics, the lower voltage can also step up to the higher voltage as well. As you can see in the picture, the 440 volt is stepped down to 220 volt. Not all electrical devices use DC power. Many devices, household appliances especially, such as lamps, washing machines and refrigerator all use AC power, which is delivered directly from the power grid via power outlets. DC primarily comes into play when a device needs to store power in batteries for further use. Smartphones, laptops, portable generators, torches, outdoor CCTV cameras, and etc. You name it. Anything battery power relies on storing DC power. Now I can correlate and remember a historic war between Nikola Tesla and Edison on AC and DC. So who won, Edison or Tesla? In fact, they both. Genius inventors and industrialists, Thomas Edison on one side, facing Nikola Tesla on the other, battled to lead the technological revolution of AC and DC that has powered humankind ever since. The another most interesting topic is semiconductors. Semiconductor is a substance, usually a solid chemical element or compound, that can conduct electricity under some conditions, but not others, making it a good medium for the control of electrical current. Semiconductor materials can be divided into two general groups, intrinsic and extrinsic. An intrinsic semiconductor is chemically very pure and its conductivity is very poor. Some common intrinsic semiconductors are single crystal of silicon, germanium, and gallium arsenide. These may be converted into the more powerful extrinsic semiconductor by adding some of the small amount of impurities. This process known as doping, which alters the electrical properties of semiconductor and improves its conductivity. For example, the atom of an intrinsic semiconductor such as elemental silicon has 4 electrons in the outermost cell. These electrons attach the silicon atom to its neighboring atom and so far are not free to move through the solid. Accordingly, since electric current rely on charge motion, pure silicon is poor conductor of electricity. If phosphorus atom with 5 outer electrons are substituted for some of the silicon atoms, the 5th electron is not needed for binding to adjacent atom and is free to move through the solid. Thus, doping silicon with phosphorus improves the silicon conductivity. Other atoms used for doping such as boron have 1 less outer electron than silicon. When they are submitted for some of the silicon atoms, each captures 1 electron from the neighboring silicon atom, leaving an empty space or a hole. Such holes behaves as they were freely moving particle with positively charged, and thus they are also served to increase the silicon conductivity again. An extrinsic semiconductor is commonly classified as N or P type depending on whether the impurity added has an excess of negative charge, that is N type, or a deficiency of negative charge, that is P. The p-type semiconductor can be defined as once the trivalent impurity atoms such as indium, gallium are added to an intrinsic semiconductor, and then it is known as p-type semiconductor. In this semiconductor, the majority charge carriers are holes, whereas minority charge carriers are electrons. The n-type semiconductor can be defined as once the pentavalent impurity atom such as Sb, arsenic, is added to intrinsic semiconductor, and then it is known as n-type semiconductor. In this semiconductor, the majority charge carriers are electrons, whereas minority charge carriers are holes. The junction of P and N forms a diode where current can flow in only one direction. A diode is a device that allows current to flow in one direction only. One side is the P side and the other side is N side. The P side is positively charged and the N side is negatively charged. Both of these sides are layered together to form what is known as NP junction, where they meet. When a negative charge is applied to the N side and the positive to the P side, electron jumps over the junction and current flows in one direction only. This is diode's core property. What are transistors? A transistor is a semiconductor device used to amplify or switch electronic signals. Transistors are one of the basic building blocks of modern electronics. It is a miniature electronic component that can do 2 different jobs. It can either amplify a signal or switch a signal. When it works as an amplifier, it takes it at a tiny electric current at one end and produces a much bigger electric current at the other end. And when it works as a switch, the smaller current switches on the large one. This is essentially how all computer chip works. For example, a memory chip contains hundreds of millions or even billions of transistors, each of which can be switched on or off individually. This is commonly used transistor. Transistor is a 3-terminal device: collector, base, and emitter. Emitter terminal is a heavily doped region as compared to 2 base and collector. This is because the work of the emitter is to supply carriers to the collector via the base. The size of the emitter is more than base but less than the collector. The size of the base region is extremely small. It is less than emitter as well as the collector. The size of the base is always kept small so that the charge carriers from the emitter and entering base will not recombine in the base region and will be directed towards the collector region. The doping intensity of base is also less than emitter and collector for the same region mentioned above. Collector. The collector terminal is moderately doped and the size of the collector region is slightly more than the emitter region because all the charge carriers coming from the emitter recombines at the base and heat is released in this process. Thus, it is necessary for the collector terminal to be large enough so that it can dissipate the heat and the device may not burn out. Now let's talk about some of the commonly used electronic components. Let's talk about our first general component, that is LED. In the simplest term, a light emitting diode is a semiconductor device that emits light when an electric current is passed through it. Light is produced when the particles that carry the current, known as electron or holes, combine together within the semiconductor material. Since light is generated within the solid semiconductor material, LEDs are described as a solid state devices. Inside the semiconductor material of the LED, the electrons and holes are contained within energy bands. The separation of the bands, that is the band gap, determines the energy of the photon, that is light particles, that are emitted by the LED. The photon energy determines the wavelength of the emitted light and hence its color. Different semiconductor materials with different band gap produces different color of light. The precise wavelength, that is the color, can be tuned by altering the composition of the light emitting or active region. The next important topic is resistors. The resistor is a passive electrical component to create resistance in the flow of electrical current. In almost all electrical network and electronic circuit they can be found. The resistance is measured in ohms. A ohms is a resistance that occurs when a current of 1 ampere passes through a resistor with 1 volt drop across the terminals. Resistors are used for many purposes. A few examples include delimiting electric current, voltage division, heat generation, matching, and load circuiting. There are others such as control gaining and fixed time constants. They are commercially available with resistance values over a range of more than 9 order of magnitude. They can be used to as electric brakes to dissipate kinetic energy from trains or be smaller than a square millimeter for electronics. So let's find out the value of a resistor. So the first color is red and the second color is yellow, and let's say the third color is orange, and the last color is all about the tolerance. It might be gold or silver. There might be no color as well. So when we have the first color, that is red, we have to go for the corresponding number, that is 2, and the second color, that is yellow, similarly, and we have to go for the table and look at the value there. So the second color is 4. The third, that is the multiplier. If you see the column there, the multiplier, you will see a value called 10 to the power 3. So we have to multiply 24 with the multiplier, that is 10 to the power 3. This gold is all about the tolerance. So it means 24 times 10 to the power 3. So G, that is gold, is all about the tolerance. And if it is gold, so we have to keep it 5%. It means the value can increase 24 into 10 to the power 3 plus minus 5%. So here 24 cross 10 cross 10 cross 10. It means 10 to the third. So it means 24,000 ohms. So the value is ohms, as it is a resistor, so it is a 24,000 ohms. So if to convert in coulomb, so we'll get 24k. So as it is G, so it will be plus minus 5%. Let's look at this color code. You can see and take a reference from this color code given in the picture. The first digit, the second digit, the third digit, and a multiplier. Let's find out the value of this resistor. Give yourself some time and find out the value of this resistor. So looking at the chart, the first digit, that is brown, is 1. The second digit, that is black, is 0. And the third digit, that is the multiplier, is 1000. So when 1, 0, that is 10, is multiplied by 1000, that is 10k. So it is 10 kilo ohm resistor. Now let's talk about capacitors. The capacitor is the component which has the ability or capacity to store energy in form of an electrical charges, producing a potential difference, that is static voltage, across its plates, much like a small rechargeable battery. In its basic form, a capacitor consists of 2 or more parallel conductive metal plates which are not connected or touching each other but are electrically separated either by air or by some form of good insulating material such as wax paper, mica, ceramic, plastic, or some form of liquid gel as used as electrolytic capacitors. The insulating layer between a capacitor plate is commonly called as dielectric. Due to the insulating layer, DC current cannot flow through the capacitor, as it blocks its allowing instead of voltage to be present across the plates in form of the electrical charges. Imagine a water tank constantly filled by a water pump, where the tap connected at house supplies a constant water flow. Though the pump is turned off, as the tank has enough water in it, it allows a constant water flow through the tap. Hence, tank acts as a storage or a capacitor. An electrolytic capacitor is a polarized capacitor whose anode or positive plate is made up of metal that forms an insulating oxide layers. These oxide layers acts as a dielectric of the capacitor. A solid, liquid, or a gel electrolyte covers the surface of the oxide layer, serving as a cathode or a negative plate of the capacitor. Due to their very thin dielectric oxide layer and enlarged anode surface, electrolytic capacitors have a much higher capacitance voltage produced per unit volume. What is dielectric? A dielectric is an electrical insulator that can be polarized by an applied electric field. When dielectrics are placed in an electric field, practically no current flows in them because, unlike metals, they have no loosely bound or free electrons that may drift through the material. Instead, electric polarization occurs. The positive charge within the dielectric are displaced magnetically in the direction opposite to the electric charge. This slight separation of the charge or the polarization reduces the electric field within the dielectric. Let's talk about IC. This is my favorite topic. If a multiple electronic components are interconnected on a single chip of semiconductor material, then the chip is called as integrated circuit. It consists of both active and passive components. Each IC has a part number and is created for a specific purpose. ICs are available in different packages. The photo shown as an IC that contains logic gates packaged in 14-pin packages, a timer IC in 8-pin packages, and a voltage regulator IC in 3-pin packages. Transistors are also available in 3-pin packages shown in the image. The part number will tell you whether it is an IC or a transistor in this package. This is done by looking up the part number using a search engine or the internet or entering the part number into a search box on the manufacturer's website. All ICs are marked with a part number no matter in which type of package they are packed. Let's talk about DIP IC. When beginning electronics, most of the ICs that are used will packaged as DIP, that is dual inline package. This photo shows a 14-pin DIP IC and 2 views of 8-pin DIP IC. IC have all numbered, example pin 1, pin 2, pin 3, etc. On a DIP, a half circle will show at which end of the IC pin number 1 is. Pin number 1 may also be marked by a dot next to pin number 1. With the dot or a half circle on the left, pin number 1 of a DIP IC will always be at the bottom left pin. Successive pins are numbered to the right of the pin number 1. When the end of the bottom of the row has been reached, numbering continues with the top right pin and continues on the top row from the right to left. The drawing below shows the top view of 8-pin DIP IC with the pin number. Now, I'm excited to know how these ICs are manufactured. Let's look at this video and understand. In the manufacturing process of IC, electronic circuits with components such as transistors are formed on the surface of silicon crystal wafer, a thin film layer that will form the wiring, transistors and other components is deposited on the wafer, which is called deposition. The thin film is coated with photoresist. The circuit pattern of the photomask, that is reticle, is then projected on the photoresist using photolithography technology. The developed photoresist is used as a mask for etching to process the thin film into the shape of wiring and other component which looks like IC. Wow, world of electronics is just mesmerizing. Let's now talk about circuit symbols. Electronic circuits, there are many electronic symbols that are used to represent or identify a basic electronic or electrical devices. They are mostly used to draw a circuit diagram and are standardized internationally by IEEE. This is a wire circuit symbol. It is used to connect one component to the other. This is joined wire circuit symbol. One device may be connected to another device through wires. This is represented by drawing a block on the point where they are soldered. This is unjoined wire circuit. When the circuit are drawn, some wires may not touch each other. This can only be shown by bringing them or by drawing them without blobs. But bridging is commonly practiced as there will not arise any confusion. Let's talk about some power supply symbols. This is a cell circuit symbol used to provide a supply for a circuit. This is a battery circuit symbol. A battery has more than a cell which is used for the same purpose. Smaller terminals is the negative and the larger one is the positive. Abbreviation is as B. If we talk about DC power supply, this is circuit symbol for DC power supply, which is used to show the current will always flow in one direction. This is AC power supply. It shows the current will keep alternating directions. This is transformer circuit symbol. It is used as an AC power supply, consists of two coils, the primary and the secondary, that are linked together through an iron core. There is no physical connection between the two coils. The principles of mutual inductance is used to obtain power. The abbreviation used for the transformer is T. This is earth circuit symbol. It is used in electronic circuit to represent the 0 volt of the power supply. It can also be defined as the real earth when it is applied in radio circuits and power circuits. This is a simple resistor symbol which is used to resist the amount of current flow through a device. Abbreviation is used as R. This is a potentiometer which is also called as variable resistance. It is used to control the voltage flow and has 3 contacts. It is having an application changing a mechanical angle change to an electrical parameter. Abbreviation is used as POT. This is a capacitor symbol. A capacitor is a device that is used to store electrical energy. It consists of 2 metal plates that are separated by a dielectric. It is applicable as a filter, that is to block DC signals and allow AC signals. Abbreviation is C. This is a different symbol of a capacitor which is polarized. It can be used in a timer circuit by adding a resistor. This is a variable capacitor which is used to vary the capacitance by turning the knob. A type of variable capacitor is a trimmer capacitor that is a small size. The notation are all the same. This is a symbol for diode. A diode is used to allow electric current to flow in one direction only. The abbreviation is D. This is a light emitting diode symbol. LED is used to emit light when a current is passed through a device. Its abbreviation is LED. And this is the most important part, that is photodiode. The photodiode works as a photodetector and converts light into the corresponding voltage or current. This is the most commonly found components in our lab. This is called LED. So LED do have 2 terminals. The longer leg called as positive, that is anode, and the shorter leg, that is negative, called as cathode. It comes in many different colors. You can see here it's blue, yellow, red, white. There are multiple number of LEDs in our lab you can explore with. These are resistors. Resistor comes with many different values. So if you see the color code of this resistor, the color code defines its own resistance value. So all the resistors do have different color codes. We have already learned how to calculate resistance value. This is a switch. A switch is basically a circuit breaker in any circuit which turns on while pressing it and turns off while releasing it. It is always connected in series. So whenever we press it, It closes the circuit. Whenever we release it, it opens the circuit. These are capacitors. To be very precise, these are electrolytic capacitors with many different values. If we see this is having 200 microfarad 25 volt capacitor. This is a different capacitor of 25 volt and 47 microfarad. These are electrolytic capacitor because they do have two different terminals, the longer leg that is positive and the shorter leg that is negative. We have already learned how this electrolytic capacitor works. There is another kind of capacitor, that is ceramic capacitor. These are ceramic capacitors. These do not have any polarity as they do have medium inside which saves electric charges. You can see it closely. These are ceramic capacitors. These are potentiometers, also called as variable resistance. These do have three legs, positive, negative and the rotor. It changes the resistance value. So this potentiometer do have 103 written on the top. It means that it is having 10 to the power 3K resistance. This is LDR. LDR changes the value of the resistance whenever the light falls over it. So this is a light dependent resistance which is also called as LDR. Can you guess what is this? This is IR LED and this is photodiode. You might be guessing it as LED, but no, these two looks like LED, but these are IR LEDs and photodiodes, a kind of LED but with different properties. The IR LED receives IR radiations and this photodiode receives photons falling onto it and change that photons into a corresponding voltage. These two LEDs are used in IR sensors. This is a commonly used IC. This is L293D motor driver IC. As we have already discussed the configuration of IC, this IC do have a notch from where we can start the numbering. I have some more IC with me. This is a 8-pin DIP IC which do have 8 legs numbering from 1 to 4 and then 5 to 8, starting the counting from the notch. When I was a kid, my parents scared me not to touch the light switch with wet hands because I would be in danger of being electric shocked. Do you know why? Let me tell you. Wet body can act as a good conductor of electricity. In case of any leakage, the person with wet hands or barefoot will get a shock. Current can easily pass through our body, but if we use an insulator for touching the electrical appliances, then we can protect ourselves with electric shock. Do you know why batteries do not give shock? But touching household electric plug gives you electric shock. Let me tell you. Batteries store small amount of electric energy ranging from 5 volt to 12 volt or more. As they are DC sources, our human body acts as a large resistance to the linear current flow from battery. This is the reason we do not get electric shock. On the other hand, our household supply works on AC sources and gives us shock of 110 to 220 volts, which is alternating. It attracts and repels at its every cycle due to its alternating nature. Do you know, walking across a carpet can generate around 35,000 volts of static electricity. As 50 volt of static electricity is enough to compromise a small electronic device. I wish I could power up my home appliances just by walking around. Do you know 90% of world's currency is digital? This means that most of the money you earn, transact with, used to buy goods or services, and so on exist only on computer hardwares. Only an estimate of 8% of currency global is physical money. Can you guess what is this? Yes, you guess it right. This is something which you might have not seen. This simple chip contains billions of transistors. A small silicon chip, of which could easily fit into our hands, contains more than 100,000 transistors. It's something which has surely struck your mind, isn't it? Isn't it interesting? Before ending the session, I am putting up two very interesting questions for you. Which power seems to be more dangerous, DC or AC? And the second question is, can you guess how small a circuit can be? Depending upon the knowledge you gain from the session, please try to answer the 2 different questions. Thank you so much for watching our video. We'll learn something different and innovative in next sessions. Take care.